woo, woo. Big dog.
What up, everybody? Welcome to Coffee Hour. My name is Paul Abernathy. Thank you for taking the time out of your day. And some of you, it's really early out there on the West Coast. Thanks for joining me for Coffee Hour. Hopefully you get something out of our shows. We do these Monday through Friday at 8 a.m. Eastern Time. So again, if you need to get your code fixed, you want to just chime in with everybody, we encourage you to share the love, let everybody know about Coffee Hour. It's the only live show that I know of, whether it's anywhere. I can say this, anywhere, whether it's regular TV, traditional TV, anywhere. It is the only live show that comes to you 5 days a week for the electrician. All right. It's Coffee Hour with me, Paul Abernathy, your host. If you don't know who I am, Google me for a minute. I have been in the industry for quite a few years. I've done a little bit of everything from inspections to engineering design to as a master electrician in multiple states. I have worked with the tools, by the way, still have the cuts to show it. I'm just older now. I work smarter rather than harder, and I teach you the National Electrical Code and all things about the NEC. So if you've first time you've joined us, one of the things we like to do is to let everybody know how they can let us know who they are, where they're from, what they got going on. And you can do that in the chat on whatever forum you're watching on. We're available on LinkedIn, we're available on Facebook, we're available on YouTube. We also have the ability for you to watch our streams live over on our own proprietary channel, which is fasttrackstube.com, as well as fasttracksystem.com. Just look for the link for Coffee Hour and you'll be able to watch it. You also can watch the shows from your mobile device. It is so easy, folks. All you do is download our free mobile app from our website, which is, again, right there on the logo. It's easy to do. All you do is get the app. Now click on it. You just click on it. And once you're in here, it looks pretty simple, right? All you do is go up here where it says event, Coffee Hour. Boom, right there. And there it is, right there, Coffee Hour. And there's me. See me right there? And then if you want to full screen it, you just hit the little feature right here and it'll full screen it. And you turn it to the side and there you go. Look at that. You can get Coffee Hour right from your phone every day. Look at that, showing you live. You also can watch the replays from there as well. We have a separate viewer just for the replays at 5 o'clock because we have a viewer for the live and then we have another viewer down below that. People wanted it. Y'all requested it to be able to watch it there as well because it's easy to get through the app. And again, the app doesn't cost you anything and we're not trying to push anything down your throat. Okay. All right. So today on this episode, we're going to be talking about swimming pools, spas, hot tubs, but we're going to be doing it at a very high level. So if you're looking for in an hour for Coffee Hour, and I know sometimes I go over an hour, sometimes, right? Womp. But if we have to do multiples, that's fine. But we want to do it at a very high level. But I want to tell you that we do have an extensive series that really does deep dive. If you haven't seen it yet, it's like 7 or 8 parts. I can't remember how many parts it is. It's over on Fast Tracks Tube. So for those that do have Fast Tracks Tube, it's over in, oops, right there, knocked my head off, over in the subscription area. And you can go over there and you can watch it under the series and you will see it's pool and spas. And it is quite extensive. And it's with me and a fellow Code Panel 17 member, Vince Delacroix. And he's a great guy. Vince is on that. And we are doing a new version for 2026 coming up towards the end of the year. So if you're in the Fast Tracks Tube, you're going to get access to it as included in your annual subscription. $99 to show your love. And you get access to all those videos. And we're constantly adding new videos. So things like that. So if you're inclined. Now, if you get Fast Track Enhanced, one of our programs, then you get 12 months of Fast Tracks Tube included, that type of thing. You can always renew it at the end of a year if you so choose, but we appreciate it. And of course, we give away free subscriptions here as well. So again, you by watching, you get a chance to join in all of that goodness. So we will be recording that, but we do have a current one that's over there now. Make sure you go check it out if you want to get a deep dive into pools, spas, hot tubs, and all those type of things. Okay. All right, let's do some real quick shout outs to live vicariously through our fellow followers here. So let's see here. Charlie, good morning. glad to have you here. Brandon's in the house down in Houston. Thank you, Brandon. Glad to have you here. Frank we are truly his morning coffee out there in Los Angeles. It is early. Woo! That's too early for me, bro. But we appreciate you. Good morning. Glad to have you here. Skyattle, good morning. Glad to have you here as well. Jonathan, shouting out to the people. Glad to have you here, Jonathan. Jonathan's from Southern Tennessee, so we got our Tennessee folks in the house. Robbie's working on a job down at the Tesla plant. Hey, Elon Musk is now leaving government work. He's done his job. He's going back to help Tesla be great. So again, wish him much success. What's up, Charlie? Glad to have you here. Coffee time is what I'm talking about. Paul, welcome again from Houston. Glad to have you, Paul. Welcome. Marlon, glad to have you here, my friend. All the code nerds are in force. Here we are early in this morning, getting into some pools, spas, hot tubs, and all that kind of good stuff. What's up, Kendra? Thank you for joining us. Glad to have you here. Let's see here. Who else we got shout outs to? Haas is in the house. Haas, thanks for joining us. Richmond, Virginia, right down the road. Right down the road. We got to do lunch or something, Haas. There we go. Let's see. Rob's in the house. Good morning, Rob. Hope everything is okay in your household. What's up, David? CMETP is in the house. There you go. Let's see. Here we got Thomas. Tom from he's down at BWI Airport right down the road. By the way, I'll let y'all know Tom took his proctored exam yesterday for the CMECP. We have not finished the grading yet, Tom, but he did well. Very good. I wouldn't expect anything else, but he did it. So those that are interested in the CMECP program, it's a real deal. 19 units. David went through it. Tom's in the final stretches of going through it. If you want to test your knowledge and raise your game, CMECP program is the way to do it. It really does make you step your game up. Okay, some of you will move through quicker than others, but again, it's all about the journey. Okay, let's see here. What's up? High Voltage Hands, good morning. Glad to have you here. Let's see. Santana's in the house from Nebraska. Got a Cornhusker in the house there. Good morning, Manny, wearing that Code Nerd green hoodie. Glad to have you here, as always, my friend. Rob, Melting Toast, good morning. I have become your Rush Limbaugh. That's a good thing, because I liked Rush. I liked Rush Limbaugh. Let's see here. Jose from the DMV. Jose, you are in the DC, Maryland, Virginia area. That is awesome. Right up the street. We're neighbors. What's up, Alex? Glad to have you here. As always, share the show with friends. Let's get 1,000 electricians joining us every morning. And also, I should add, over on the Facebook, you should subscribe. That's been our longest social platform, and we're going to keep that one. No matter what happens to our other stuff, Master the NEC, just search for Master the NEC. That one over on Facebook has been our longest running. Probably maybe not as long as YouTube, but as far as our interaction location, there's only about 7,000 members there. But I encourage you to share it with other people. We don't want any riffraff over there. It's just basically me sharing content. But what I did was I posted something asking for you to comment on future topics that you want to hear. Again, we want to make these shows about what you want to hear. Same as this pool and spa, I was asked to do this show by a member who sent it in through paulabernathy.com and said, Paul, can you do a quick overview or give me some of the most important aspects of pools, spas, and hot tubs to take away? And since I serve on Code Panel 17, any insights that you want to give that can enhance, because he's a pool contractor as well as an electrician. And so I said, sure, I can do that. It was all because he requested it. So this is for you. You know who you are. Let's see here. And you are in the house. So glad to have you here. What's up, Edgar? Glad to have you here, my friend. Welcome. David's in the house from Nebraska. We got people from all over. Glad to have you here, David. What's up, Cray Cray from Nashville, Music City? Funny, country music just is not the same as it used to be, but there's this new artist. I don't know how new he is. If you're into country music or you like country music, there's this guy called Zach Tops. I love it. I love his new song that came out, "As I Never Lie." It's amazing. He's a great young artist, and he's kind of reminds me of a back in the '90s, and when I was listening to Clint Black and all those stuff. So I'm a country guy. I love country, although most people know I love my '70s. So I listen Spotify. I listen to all types of things. Alexa, I know I listen to '70s on 7 from XM, and but I love my country. I love bluegrass, all this kind of stuff. But Zach Tops is very refreshing. Another artist that I love, in case you're just dropping names of artists, if you're a country music fan, and just an instrumentalist, is this gentleman called Billy Strings. I don't know if you've had a chance, if you're into country music or bluegrass or any of that type of thing, if you listen to a guy called Billy Strings, look him up on YouTube. What an amazing artist. Anyway, now you know what my playlist is of the type of people that I listen to. Okay? But I still love my '70s. I'm a Bee Gees fan by heart. You know what I'm saying? Let's see here. Let's see. What's up, Jose? Former Fast Tracks Black member before we transitioned. Absolutely. Up in Maryland, D.C. Grateful. Awesome. You put in the time, you can make it work. Thank you, sir. I appreciate that testimonial. Again, there's a lot of people out there teaching. There's a lot of people who have hung their shingle out. But again, it's those that have been around for a long time that have been teaching it, and we have the testimonials to prove it. So we appreciate you. What's up, Mitch? Out in Florida. Glad to have you, Mitch. Thanks for joining us today. Let's see here. Yes, I agree with Frank. Let's everybody hit the like, whatever platform you're on. Let's share it. Again, even my haters, you got to come to realize that I'm just here to teach you. You can agree to disagree. You have a choice to turn it off. Just like I don't have to watch certain shows on TV. If I don't like it, turn it off. So there shouldn't be any reason for a hater to ever be on my channel, because if you don't like it, then you shouldn't subscribe. I should only have people that follow us and watch our stuff that like us. Because if you're a hater and you don't like it, why are you watching? That's what I never understood, the down arrow thing. I have never thumbed down anybody on any video I ever watched, because I make the determination if I don't like the video, then I just don't watch it and I don't subscribe. So I don't understand the concept of so much hate. If we're giving you a little bit of something that you learn from it, isn't that a good thing? But anyway, people are people, and it is what it is. Let's see here. Nepo, good morning. Glad to have you here. Columbia, South Carolina. I'm jonesing for some crabs. I'm trying to reach out to a crab dealer that's up here and near Chesapeake Bay, because I have not had Chesapeake Bay crabs, bluefin crabs. Believe it or not, it's my favorite food ever. And I haven't had them in 10 years because I moved to Texas and it's so tough to get them. Now I'm back in Virginia. I am jonesing for some bluefin crabs. So I think I found somebody that I'm gonna be able to get a bushel of them from, and hopefully I'm gonna get them, because I'm gonna sit down and eat me a couple dozen of them things. What's up, Mike? Glad to have you here. I grew up on them, eating them all the time. So, what's up, Brandon? Has that '90s vibe? Yes, Zach is a freaking amazing dude. What's up, Greg? Glad to have you here. Thanks for joining us. There you go, Brandon. Staying Alive, all-time favorites. Top favorite, one of my favorite movies ever is Saturday Night Fever, and I love the Bee Gees, that they have all the music for that. What's up, Adrian? Glad to have you here. We have multiple people down in Houston. That is awesome. All right, folks. Again, as always, let me know in the comments where you're from. And I do see you folks over there on Instagram. I don't know if your comments show up here. I don't think they do. They haven't figured that out yet over on EV Mux, who we use to do our show. But I do recognize all of you, and I appreciate all of you for following over on Instagram. Don't have a big following over there. I'm not as funny or fun to watch as some of the other stuff, so I don't, I'm an acquired, how do I say it? I'm an acquired taste. You got to get used to somebody like me, right? All right, so let's go on and get into today's lesson. Oh, real quick, before I get into today's lesson, there is the code question of the day from Nika. Let's see here. So let's see. We want to do that, and let's see if we can answer this question. So here's the code question of the day. It says, good morning, code question of the day. And somebody asked if I would do these more. So I said, yes, I'm more than happy to do that. let's see. Maybe I can even make this easier so you can comment. There you go. That'll work. Code question of the day. It says, I'm feeding a 3-phase panel board in a commercial office build out, and someone said we don't need to pull a neutral since all of the loads are 208 volt, 240 volt. That would have that would save some effort and wire. But I'm worried that might come back to bite us later. Are there specific rules about when a neutral is required? Okay, so interesting topic. So in all cases when services, you are required to bring a grounded conductor, in most cases a neutral, to the service, right? Because that's your return path to the source, right? But the code does not require me to take a neutral downstream to a piece of equipment that doesn't require a neutral. You still always got to have an equipment ground. But one thing I'll remind you is it requires a minimum size, but it doesn't require you to install the neutral. So if I have a motor that has no neutral, then I don't have no need to take a neutral. I mean, what am I going to do with it, right? The one thing that I would encourage folks to remember is that in multi-wire branch circuits, you're going to need that neutral to carry the maximum imbalance. If you're going to have any possibility of 120 volt loads in the future in a panel, obviously you're going to need the neutral, right? So a prudent design criteria would be that I should pull a neutral, but it's not a requirement. It is a requirement to bring it to the service, but it is not a requirement to take it downstream. Now, there's minimum sizing requirements, as David's pointed out. There are all types of requirements where a neutral is necessary, but it is not, if it's not required on a specific piece of equipment, then I don't have to take a neutral to it. But don't confuse that with the need for an equipment ground. You still need the equipment ground. You still have to clear an overcurrent protected device. And I think it's important that folks understand there's a vast difference between needing a neutral in order to be able to get loads like 120 volt loads. If I have purely 240 volt loads, then I don't need a neutral. Another good example is some EV chargers. Some EV hardwired chargers that do not have 120 volt, and I'm going to say majority of them do because of electronics and digital monitors and all that kind of stuff on them. But if there was something that was purely 240 and it had 0 neutral loads, then we would say, okay, then we don't need it. So Dan says, well, what does the hog say? Oh, shit, that's a good question, Dan. Dude, Dan, you're a sharp cat. So let's go over here. Let's say, all right? Yep, David says it's just for the service. It's not talking about anything to do. If you don't need it downstream, you don't need it downstream. So let's see here. I'm going to copy this, okay? Copy. And we'll go here to TradeHog. And let's see here. Let's see. We'll share this instead. All right, so we're at TradeHog. Let's go to the full screen TradeHog, okay? Why not? All right, let's go to, let's see, full screen. That is full screen TradeHog. All right, so that's good enough. All right, let's go down here and I will paste it right here. So this is the question that was asked, right? And I'll click select. Let's see what the hog has to say. Hog is thinking. All right, let's see. In a commercial setting, whether or not a neutral conductor is required depends on the type of loads being served in the panel board. Okay, I agree with that. It says, according to the NEC, a neutral conductor is not required if all the loads are balanced 3-phase loads that do not require a neutral connection, such as a 208 volt or 240 volt load. However, if there is any possibility in the future that might require neutrals, or if there are any single-phase loads that require a neutral, it would be prudent to include a neutral conductor. That is because adding a neutral later could be more costly and complicated. That is so freaking true because you know what? You might not size the raceway for it. And if you don't size the raceway for it, you're not going to add another conductor later. And you could have potential where you damage the conductors trying to pull them in later, right? That makes sense to me. So the NEC does not explicitly require a neutral conductor for a three-phase panel board if all the loads are balanced and do not require a neutral. However, 200.2a states that a grounded conductor neutral is required where it is necessary to supply a load, and that would be loads that require a neutral, okay? Additionally, 408.41 requires that each grounded conductor neutral terminated within a panel board, which implies that if any load requires a neutral, it must be provided, okay? Therefore, while you may not need a neutral for the current configuration considering future flexibility and potential changes in the load requirements, if there are any changes in the future, loads might require a neutral. It would be wise to include one to avoid future complications. Hog for the win. Hog for the win, because I agree wholeheartedly with that application. Yeah, was it going to save you a conductor? Is it going to save you anything? Maybe Raceway might be a little smaller. Probably not. You're probably not going to worry about that. You're probably nowhere near 40% fill. My advice is, can you, if you have no neutral loads or no need, yes, that's fine. You can not have it. My advice would be to pull one and put one in, okay? And you don't terminate anything to it, that's fine. Now, where I differ on that, obviously that's for panel board applications or panel enclosures. When it comes to specific loads that no neutral is required, then what's the point? What are you going to do with the neutral? If I have three-phase loads and I'm pulling it out to a motor and no neutral is required, what the heck am I going to do with it? You get me? If it's a motor that doesn't require neutrals, then why pull one? Okay, so hopefully that answers the question. That is the NECA question today. Okay, yeah, David, I'm with you. If I'm doing a panel, I'm probably always, it's not even going to cross my mind, I'm always going to pull a neutral. I'm just the way I am. You might say, well, but there are occasions in some facilities, industrial facilities, where the only thing that's being fed out of that panel, the only thing that will ever, and this is often design, right? This is by design. The only thing I'm ever going to come out of that panel, so there's a set of drawings, it's industrial or whatever it is, and the only thing that's ever going to come out of that panel is going to be loads with zero neutrals. There's never going to be a neutral in that panel. Then it might make sense to do so, okay? But you know as well as I do that one time that somebody down the road, somebody comes along and says, dude, I'd really like to have a 120-volt circuit right here or something right here. And you're like, oh, God. The panel to get 120 volts is all the way up in the front of the building. I mean, that's 350 feet way up there. Oh, my God. We got a panel right here. And some wise butt comes out and says, well, just take the hot conductor and then connect it to the ground. They both go back to the same place. Womp, womp, womp. No, don't do that. But can't you see some smart aleck doing that? Because they always use that. I can see this on social media. Somebody going, oh, but wait, they both go back to the same place. I'll just use the equipment ground to get me the one. Can't you? You and I both know you see that happening, right? So for me, install a neutral and just do it, that type of thing. But when you go from the panel out to a motor, for example, or a piece of equipment that doesn't have a neutral, then it's pointless to take a neutral. I mean, what are you going to do with it? It's just, you're not going to do anything with it, okay? Yeah, so we can't fix stupid, but we can think about how we do things to try to mitigate stupidity. Is that a good way to say it? All we try to do in the code sometimes is try to mitigate stupidity, right? And that happens all the time for grounding and bonding. People can go way too far for grounding and bonding, that type of thing. Oh, another thing that I wanted to point out, because somebody asked me this, and I don't know if I talked about this. Man, you're getting a lot of good stuff already today. Somebody asked me, they said, Paul, can you ever, what's up, Red Dog?
Woo, 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 woo. Big dog.
Somebody asked me, could you ever use a lock nut at a service? Not a standard lock nut, I'll explain the difference. A lock nut at a service for service bonding to meet the requirements of 250.92b. And the answer to that is, and you're going to have a lot of educators that say never. I'm going to tell you they're wrong. Because if I have a fitting that is evaluated under UL 467, and it's a difference between a normal, like a compression connector for EMT, like in a wet location, a compression connector that you put the EMT into it, you tighten it down, and it has the threads connector, and it goes into a panel. You can't use a standard lock nut. However, those all normal fittings for service or regular applications are evaluated under what's called UL 514B. However, there are a select group of fittings that are evaluated under UL 467, which is fittings that are evaluated for grounding and bonding applications. Now that's different because in those, and I have a picture somewhere, and I should have added it, but basically it's made by, I think, a company called American Fitting or something like that. Just an example, they make one that's a compression, okay? It's wet location rated. It's a compression for EMT. It's got threads on it. It goes into an actual service application or regular, it doesn't matter, okay? Because a lot of people use it in hazardous locations. It goes in and it comes with its own lock nut. And people are gonna say, oh, but the code says standard. That's why the code says standard lock nuts are not to be used. That is not a standard lock nut. That lock nut has been evaluated with that connector under UL 467. That is different from a standard connector that gets evaluated under UL 514B. So if anybody ever tells you that you never can use a lock nut on a piece of equipment for that, they are wrong, okay? Because if you get something, look for it to say UL 467. If it says that on the connector, then it's been evaluated for grounding and bonding. Other than that, you can't use a standard lock nut like you would get on a normal set screw fitting or something like that for service bonding, okay? That type of thing. And so always remember that. Now, the only caveat to use that lock nut that's in that listing, that's UL 467, that special connector, the only caveat is that there can't be any KOs in it. All the KOs have to be gone, or it has to be a punched hole, okay? That type of thing. But if you do that, you're probably not going to pay the money for a special connector. At that point, you're probably just going to, if you punch all of them out, then you're probably just going to use a bonding lock nut anyway. You know what I'm saying? But I just want you to know they do make fittings that are evaluated for that lock nut to be used with that, and it is not considered a standard lock nut, okay? It is listed as part of that UL 467 fitting, okay? I don't know if you knew that or not, but they are out there. And all you got to do is look and see if it has UL 467 marked on it as well, or on the literature, or on the product sheet, or on the box, or something like that. And will you pay more for them? Probably, because they have that extra grounding and bonding listing, other than a normal UL 514B, which is more mechanical, and it's designed to be listed to work with the wiring method or with the raceway. So if the raceway is listed for an equipment grounding conductor, then obviously the fitting that's listed for use with it continues that connection. But that is different than what we have to do on a service. So I figured I'd throw that out there because maybe you didn't know there was a UL 467 available. Check it out. It is. And look for a fitting. In fact, go on and go to TradeHog and ask them for a manufacturer that makes a UL 467 fitting for use with EMT compression and see what it brings back for you. Check it out. That's another way to use TradeHog. All right, let's get into today's lesson, okay? All right. So we're going to be talking pools, spas, hot tubs. This may be multi-part series depending on how today goes. Again, I'm already 32 minutes in. So again, shout outs being what they be, okay? So here we go. All right. So we're going to be talking about, in this unit, we're going to be talking about explaining the importance of proper swimming pool wiring regarding human safety. We're going to be explaining the hazards of electric shock associated with faulty wiring on or near swimming pools. A lot of issues like this came up out in Texas. We're down near, I don't know if it's near Houston or Austin, where there was a case where electricians installed something and did not put GFCI protection, trying to cut some corners. Somebody got killed, and all of a sudden the electricians, believe it or not, they're the ones that are being held accountable, and they should be. Okay. Summarize the basic NEC requirements. Now, this is going to be a summary, very high level, but it's going to give you something for you to know where to go to look them up. And of course, if you have any questions when it comes to pools, spas, hot tubs, dude, I am more than happy to answer those questions. And that's what we're here for at Coffee Hour, to ask those questions if you have them. So again, we're just here to chew the fat and enjoy the conversation. And also at the end, we'll look at some UL standards that if you deal with pools, spas, hot tubs, and things like that, that you need to be familiar with. Different UL standards for different applications for GFCIs, 943, all these type of just things for you to be more familiar with. So that's what we'll cover in today's episode. Hopefully we'll get done. Introduction. We're going to be talking about the risk. The electric shock and electrocution increases significantly when people are associated with water, and electricity and water do not mix. Water itself is not a good conductor if it is like a distilled or pure water without impurities in it or other contaminants. The moment that everything that we do, whether it's pools or the water, even the water from a well is going to have minerals, components in it that make it conductive. If you have pure distilled water, it's not a good insulator, and it's not. Well, distilled water can be. It's not very conductive. The moment that you add all of this crap in it or things in it that we most of the time can't control, then it becomes conductive. Now, when we're talking about pools, there's chemicals in it. There's other things in it. There's human, in a lot of times, nasty human, stuff in it. All kinds of stuff in a swimming pool. So again, at that point, it becomes very conductive. All right. So to protect people against the hazards of electric shock associated with the swimming pool, spas and hot tubs, even hydromassage bathtubs. Okay. Do you know the difference between a hot tub and a hydromassage bathtub? Well, the hydromassage bathtub, you drain the water after every use. And the vast majority of the hydromassage bathtubs do not have a dedicated heating source. It's usually the water coming from your plumbing system that will heat the water. Okay, but the main thing is the draining of the water, that type of scenario. And also electrically powered pool lifts. Those are becoming very popular for ADA applications, mounted next to pools, allow people to help them down into the pool so everybody can enjoy the benefits of a swimming pool. And so we'll look at those necessary requirements. All right, let's talk a little bit about, and we're going through this now this is out of our residential program, which isn't available anymore, but we will be putting together a swimming pool, spas, and hot tub mini course that will be available on our website for those that are interested in it. Okay, and we'll be incorporating videos as well to add into that. Electrical hazards. A person can suffer an immobilizing or lethal shock in a residential type pool. I should say even a commercial type pool as well, any swimming pool, okay? In either two ways. Two ways that you can have a immobilizing, causing you to drown, or a lethal shock, which can electrocute you. Ultimately, the vast majority of this is probably drowning, okay? So let's see here. Direct contact. There's the first way. All right, so direct contact, it says. Now, the far as the concept, Santana asks saltwater pools. It's all about the filtration system. Saltwater pool, there's no different. One is you put chemicals in it. The other you have more components sometimes with a saltwater system, but there's no real difference in that as far as the code's concerned, as far as the NEC is concerned, as far as 680 is concerned. Still have your equipotential bonding requirements. You still have all your metal parts within 5 feet of the pool have to be bonded to the equipotential bonding grid. All the same rules. You just have maybe more things that you have to run circuits to, other components, saltwater filtration component, things like that. So other than that, no, not much different. Okay, so direct contact says an electric shock can be deadly to someone in a pool who touches a live wire or touches an object such as a metal ladder, metal fence, metal parts of a luminaire. Okay, you have wet niches, you have dry niches, and you have no niches. Okay, the niche is typically formed in the forming shell, and the actual luminaire will mount into the actual forming shell. And then typically there's a cord that runs up from that. Most wet niches, water is going to be involved in the niche itself. Dry niches, it's sealed out. And then no niches, it's just you buy it, and it mounts, and it has mounting brackets, and there's no niche involved. The whole luminaire mounts onto the pool structure, that type of thing. But one of the things to remember is that all these metal parts, metal enclosures for equipment, including electrical powered pool lift or appliances that have become live by an underground conductor in contact with the metal enclosure or exposed metal parts of an appliance. Okay. And so if you look at this illustration right here, okay. So touching a energized faulty appliance can cause a lethal shock. So this gentleman is swimming in his pool. Obviously somebody put a receptacle too close to the pool and plugged up a radio, and there's some kind of fault on the radio or something to that nature, and it gets energized. And since you know that the pool shell, okay, the pool shell is referenced to 0 because that's connected to the equipotential bonding grid. If it's a conductive pool shell, we'll talk about that a little later. And so it's connected, it's with the earth, so it's at 0 potential, the same as the earth. And now you touch something like a radio, and you'll see the voltage gradient will go through, because again, how do you get shocked? It's at difference of potential. That's how you get shocked. If everything's bonded together at the same potential, you may not feel it. But in this case, since you're swimming in a pool and the pool shell is at 0, okay, so it's connected to earth, right? So we'll say this is a gunite pool with a rebar reinforcing, and it's blown in concrete, like we call it a gunite, okay, a pliable type concrete mixture. And from this touch point, the voltage gradient goes to 0, and so you are going to feel that through your body, okay? And your body is obviously made of a certain resistance. Now, the problem with this application right here is because of this voltage gradient, the current will pass through you, and it does not take a lot, okay, to cause you to your equilibrium to get messed up, to you to freeze up, and all of a sudden lock up, and you lose your motor skills, and all of a sudden you end up drowning. Okay, and so that's so in this case, this is a direct application where you're actually in the water, and you're being the conductive component in this item, whatever it may be, metal part, whatever it is energized, and you come in contact with it. Okay, so you actually touch it. Now you're part of that gradient path. Okay. So a person touches an energized faulty appliance, current flows through the body to ground, resulting in a lethal shock. The conductive pool shell is at 0, or what we consider earth potential. Okay, this is what we do when we create an equipotential bonding grid. Now, some people have asked me, this is where I had a big debate one time with somebody very high up, okay, very high up in NFPA. And I was told by manufacturers, remember, I used to work for NEMA, and I had a talk with one of the manufacturers of the GFCIs, and they said, Paul, do you know one of the other reasons that we have a requirement in the code to bond the water? I go, well, elaborate, tell me a little bit. They say, because look, what if you had if you have a conductive pool shell, then all of the water is in contact with the conductive pool shell, so there's no need to bond the water because it's all bonded. I'm like, okay, I grant it. And I said, so if current on a circuit is traveling back through other return paths, and you're required to tie all this stuff together, then there is a high probability that a GFCI would function. Okay, that makes sense because that's the concept. If the current is traveling back on another path that wasn't the intentional path, okay, even though the earth is very high resistance, okay, You say, okay, I get you. They said, then you have a greater chance of being able to clear an overcurrent device. A ground fault circuit interrupter. I said, that makes sense. They said, well, when you have a non-conductive pool shell, like a fiberglass pool or a vinyl liner pool, then you don't have that conductive pool shell. Okay. Well, you're still required to put that 3-foot equipotential bond around the pool so that you have that touch potential. So it's at the same potential whether you're in the pool or you step out of it, right? But not in the pool. So if something falls into the pool, it can stay energized because it's isolated. There's no way to give a potential return path that's outside of the toroidal coil of the GFCI. So it may not function. Now, that makes sense. That made sense to me because if I take a GFCI and I were to touch it, the hot neutral, it's not necessarily going to trip the GFCI. But if I touch the hot and provide another path that it can get outside and return current can get outside of the toroidal coil, then guess what? It's going to trip the GFCI. So it started making sense while we bond the water. Now, it is also to bring it at the same potential as the outside perimeter for touch potential. Because current is generated because we have differences of potential, right? The voltage is always going to be present on the earth. Because of how we do utility systems and concentric neutrals and all the stuff like that, improperly done systems where the grounding electrode system may be improperly connected downstream as an improper case to neutral. So we're feeding current into the earth. Current is going to travel on the earth. It just can't be used as an effective ground fault current path. But current is going to be traveling on the earth depending on the installation. So it's potentially always present. So there's always that hazard there. So when it comes to pool bonding, we're doing all of this extra tying metal parts and everything together, not because we think we can eliminate anything. We're not. All we're doing is bringing everything up to the same potential so that if we do come in contact with it, my 1 foot is here in the water, my other foot steps on within 3 feet as I'm stepping out of the pool, it's not going to feel any difference. They're at the same potential. So there's no way for current to be, from point A to point B. So I'm not going to feel the effects. Is it there? Yes. Am I going to feel it? No. Okay. So that's an important concept. It's also important to understand that that's the same kind of concept we do on the supply side when we bond all the metal parts. We're trying to put everything at the same potential. We're not removing a hazard 100% because, the code can't remove all hazards 100%. It's a good effort. It's the best we can do. But equipotential bonding is extremely important because you're not going to get rid of current that are going. Now, some people say, well, then why do we do anything with the water when it comes to a pool that's a vinyl or fiberglass? Because you have other things that could be introduced into the pool. Okay. And so we need to have that potential to be able to give an ability for GFCI devices to be able to function as well. But anyway, I explained that at a meeting and the NFPA guy, he was like, Paul, you can't say that. I can say that because that's what the manufacturers of the GFCI told me back then. Now, if it's different now, I'm encouraging them to correct me, but it would make sense to me why you still have the requirement to bond the water even if you have a totally isolated pool. Okay, so anyway, thought that was kind of interesting. All right, so this, though, is different. So this is a direct, okay, this is direct touching it. You're reaching out, touching it, and now, again, current's traveling through you to the earth. And again, all those points in your grounding electrode system, right, has, ground rods or whatever. So everything is, so again, it is the potential. And then, of course, you're going to have also the resistance here due to the graduated effect of the water. I have a better chance at clearing a GFCI. Okay, I have a better chance at doing it if I bond the water, as well as all this other components all connected together. Okay, but anyway, the code requires us to keep receptacles and certain things a certain distance anyway, which we'll look at. All right, so this right here, direct connection. Okay, an indirect connection. Okay, that's the first way. You can just reach out and grab something and get shocked. Okay, makes sense. Don't do this right here, by the way. Don't stick your radios next to it. Use Bluetooth devices and all that kind of stuff. You don't need to do this. Nobody needs to do this anymore. Indirect contact. What can happen? Okay, an electric shock can be lethal to someone in a pool if the person is merely in the water when voltage gradients in the water are present. And they're going to be present due to the chemicals in the water and in different saturation concentrations and all that kind of stuff. You're going to have that. So here's an example. This person's just swimming in the water. But your 5-year-old child comes along and throws this radio in the water. It's still plugged in. Okay, so now it's in the water. And again, we have this zero potential, which again, in this case, is a conductive pool shell. Right? Now, if it is bonding the water and it's not a conductive pool shell, then we have to use other means like putting something in the water circulation system or something in the skimmer or something that's going to make that water contact. Maybe it's one of the rails or metal that you can use and it has enough surface area to be able to qualify. Somehow we bond that water. Okay. But in this case, because of voltage gradient, okay, this person can get shocked. Now, what's probably going to happen here, they may get locked up onto something, but usually if it's some kind of appliance, they'll probably let go, that type of thing. And that may be the only thing that saves them, okay, depending on your system or how much gradients you've got, okay. In this scenario right here, it could cause the person, because of the voltage in the water, what happens here, or the current that's passing through, what happens is they get discombobulated. That's a word? Can I use that word? They get disoriented, equilibrium, the inner ear, all this type of stuff. And the next thing you know, they also could go into where the heart goes into defibrillation, no, I should say fibrillation, where the heart just flutters. Doesn't actually pump any blood, just flutters, okay? So it goes into that, and you have to use a defibrillator to put it back into rhythm. But it can cause problems, people to get distressed in this situation, and they ultimately drown. The vast majority of deaths in a pool are not going to be by direct contact. It's going to be by indirect contact in a swimming pool. So again, I can't emphasize enough the importance of creating that equipotential bonding grid and why we have to rely on it. Now, as shown in 30.2, that's this one right here. As shown in here, the rings, and here's your different rings, okay? Rings of voltage radiating outward from the radio to the pool wall and to the bottom of the pool. These rings can be likened to the rings that form like a rock is thrown into the water, the ripple effect, okay? The voltage rings or gradients range from 120 volts at the radio to 0 volts at the pool wall or at the bottom, okay? The pool walls and bottom are assumed to be part of the conductive pool shell and at ground or zero potential. The gradients in varying degrees are found throughout the body of the water. Figure 30-2, which was this one right here, this is the one we looked at, show voltage gradients in the pool at 90 volts and 60 volts, okay? So 90 volts here, and then by the time it goes through the gradients in its path down to 0, you're in this 90 volts and 30 volt zone, depending on where you're at in the pool, that type of thing, okay? So that's your voltage gradient. That's what your voltage are that you're going to be experiencing, okay? It says, the figure is a simplification of the actual situation in which there are many voltage gradients. In this case, the voltage difference, 30 volts, okay, from 60 to 90, 30 volts, is an extremely hazardous value, okay? It says the person in the pool immersed in such voltage gradients is subject to severe shock, immobilization, which can result in drowning or actual electrocution. Tests conducted, so they did tests over the years, have shown that a voltage gradient, folks, of 1.5 volts per foot can cause paralysis. Do not be that guy who goes and does swimming pools and are not anal about making sure the bonding is done, the grounding is done, everything is done properly. Don't be that guy, because there's every day somebody steps into a pool, there's a possibility of an issue, and you want to make it as safe. And again, if they're going to sue, they're going to sue, and they're going to go after everybody, okay? So it says the shock hazard to the person in the pool is quite different from that of a normal touch shock hazard to a person not submerged in water. Why is that? Well, the water, including the various pool-related chemicals, makes contact with the entire skin surface of the body rather than just the points of contact when you may have touch contact when it's talking about outside of a pool. Your whole body's in the pool. The whole body, all that surface area is in contact. Okay, so if you have any skin wounds, such as cuts and scratches, what is that going to do at that location? Like me, I got cuts and scratches all over me. What is that going to do? That's going to reduce the body's resistance to shock. It's going to reduce it down, okay? And much lower at that point than just on your skin alone. The body openings such as ears, nose, and mouth further reduce the body's resistance. As Ohm's law states, for a given voltage, remember this now, the lower the resistance, the higher the current. So when we talk about voltage gradients, ultimately at the end of the day, as your body's into it, your body's resistance will lower the skin, the orifice, the wounds. Anyway, it will actually lower your body's resistance. So what ultimately is going to get you? It's the current. And this is going to cause you to be immobilized. So that's why you hear people say pool voltage gradients, or they'll say the current, because they're all relative and they're inversely proportional. The lower the resistance, the higher the current that's going to pass through. And again, the human body, surface area, open orifices, cuts, screws, things like that. Children got cuts, all of them. All those type of things are going to increase the possibility of electrocution, or at worst, we're talking about drowning, that type of thing. All right, some key requirements to be aware of when you're working in it. So I like to give you these because it's so important that you understand the structure. 680 is not hard, okay? You can learn 680 if you just take it by piecemeal, but there are some key things when it comes to 680 that we want to lock away in our memory, right? So Article 680 covers construction and installation of electrical equipment for and adjacent to, okay? Because you're going to have bonding requirements for things that are within 5 feet, for example, of the top inside edge of the pool. Things like that. There's going to be requirements for luminaires, where they're at on the system, where they're installed, whether existing or new. So we have all these things. All of this is going to be covered by Article 680, and it is many parts to do this. So it talks about swimming pools, wading pools, hydro massage bathtubs, typically inside of your house, okay? We're talking about, and those differ, by the way, than therapeutic pools or therapeutic tubs. Very different. Therapeutic tubs are typically factory designed. You get them. They typically have all of their components, the heating, the movement, the water, everything built into it, used as like physical therapy. Whereas a hydro massage bathtub is typically what you may have in your home, where you have a whirlpool or something like that, and you add hot water to it, and you just have a motor that moves the water around. Those are typically your hydro massage bathtubs. So don't confuse those and not all hydro massage bathtubs are considered hot tubs. Okay, they don't have a heating element to them, that type of thing. All right, where are we at? Okay, so decorative pools, maybe just like Vegas, you see those pools that are decorative, that type of thing. Fountains that are just there to kind of maybe give an aesthetic look. You got to be careful with fountains, because there is fountains that may be connected to a swimming pool, or they may be connected to another type of a pool that actually raises it to more of a concern than it would be if it was just a fountain. But we have our rules for fountains. Hot tubs, again, fairly straightforward with hot tubs. But again, I do see them wrong all the time, especially on social media. And of course, hot tub spas and even electrically powered pool lifts are going to be covered. Now, here are some things that are covered. So general code rules, generally applying broadly throughout 680. This is what you need to remember so that you don't get lost in the structure of 680 as we get deeper into this. I don't want you to lose structure. Number 1, part 1, general. It contains the general requirements that apply to all types of swimming pools, spas, hot tubs, and similar water-related equipment. This right here, folks, is something I really want you to remember, okay? Right? So there's no such thing as a concrete pool with a vinyl liner. When it comes to this concept, if it's a concrete pool, then it has rebar in it, then it is a conductive pool shell, right? If they put a liner over it, then the code said if it's a vinyl lined pool, then it is considered not a conductive pool shell. You're going to have to work with your local AHJ to determine, but if it is a concrete structure and it's poured, most of the ones that I've dealt with are not, the vinyl liner ones are not a concrete pool. But if it is concrete and it's not a concrete, it's a conductive pool shell if it's concrete and it has rebar in it and it's not encapsulated rebar. If it's connected to it, then I consider that a conductive pool shell, whether they put a vinyl liner or not. So you have to work that out with your local AHJ. But the code says a pool with a vinyl lining is not considered a conductive pool shell. So again, you could argue that it is not a conductive pool shell. Most of the ones that I dealt with were not concrete, and the base floor was sand, and the sides were framed out. It was not concrete. Okay, so again, maybe you have somebody that did a concrete pool and they choose to, because it leaked, maybe they chose to install a vinyl liner over it. Well, it would still be a conductive pool shell to me, regardless of whether they put a pool liner in it. But you'll need to check and get clarification from your AHJ. Okay. All right. So first things first, part 1 covers all of these things. So when you're looking at 680, remember, part 1 is general, applies broadly. Okay. Then you get into other aspects. Part 2, part 3, part 4, part 5, part 6, part 7, and part 8. Those specific parts cover the wiring requirements for special equipment covered within those parts. Okay. So part 1 applies broadly. Okay. So you'll have some general rules in there broadly. Then you'll have your individual parts 2 through 8. Okay. Those are specifically germane to those special wiring methods and special wiring requirements for those special equipment that's covered within those parts. Okay. Then it is important for you to know that also, even though part 1 applies generally, here you've got part 6, part 7, and part 8. Those are standalone within Article 680. And the provisions of part 1, general, only apply when they're referenced. Okay? That's important. Understand that referencing. So you have General 1, generally applies to all applications, right? And then you have some special things that are in 6, 7, and 8, and those are standalone. They will make reference back to part 1 where applicable. Okay? Important to understand that concept of how the structure. So part 1 is general. That's going to apply to the general applications, pools, spas, hot tubs, and water-related equipment. Then you'll have part 2 through 8 that's going to have specific wiring requirements, installation type of requirements for those applications, right? Specific, okay? And then you're going to have standalone requirements in 6, 7, and 8. And where necessary, they're going to make reference back to part 1 general requirements, okay? All right, so let's look at the scope. What are we talking about? So what does 680 deal with? All right, so when you see it grayed out like this and you see this little asterisk, this is letting you know that there's no need for you to pull away and go to the NEC, because this here is verbatim, directly cut and paste, extracted directly from the National Electrical Code. It says the provisions of this article apply to the construction and installation of electrical wiring for and the equipment in or adjacent to all swimming, wading, therapeutic, decorative pools, fountains, hot tubs, spas, hydromassage bathtubs, whether permanently installed or storable, by the way, and to metallic auxiliary equipment such as pumps, filters, similar equipment. Notice it says to metallic auxiliary equipment, okay? Obviously, you're not going to bond plastic. Let's just get that out of the way, because there's always There's always somebody that asks that. It says the term body of water used throughout part 1 in the general applies to all bodies of water covered in the scope of this unless otherwise amended. Okay. So again, the reference to when it says something about all bodies of water, okay, in part 1, it's very broad. Now, we're not talking about natural bodies in 682. We're talking about those that are within the scope here, pools, spas, hot tubs, things like that, all that application. They have their own rules in 682 for things like man-made lakes and ponds and all that kind of stuff. Totally different, okay? The scope of this article is important. First stop when researching what requirements apply to the electrical installation. In the case of swimming pools and related installations, Article 680 is so important to provide safety to people who have increased vulnerability due to mixing people, water, and electricity in the same environment. This is why you hire your pool contractor, and this is why you hire an electrician that's not new or doesn't know anything about swimming pools. Now, I know everybody's got to learn. And the old saying is hire somebody that's qualified. If you have never done the bonding and grounding of a swimming pool, I guess you got to learn somewhere. But I would say take some time, do some research, ask enough questions, make sure you feel diligent. In your mind, I want you to build the electrical system, the electrical bonding. And in your mind, draw out how you would do it, right? Before you actually do it. Because again, if you screw it up and once that concrete's poured and everything's in and you miss a connection, it is a nightmare. I tell you what, I could not give you a value of the number of times I had people call me and say, Paul, we forgot to get it inspected. Or Paul, we didn't put in the equipotential bonding grid. We didn't do that properly. We didn't follow the code. And now we're getting called out for it. Now the concrete's already in, Paul. What do we do? What do we do? Well, it sucks to be you. Because there is no easy fix to that, okay? The code is the code, okay? You're not driving ground rods everywhere and trying to think that that's going to solve it. You're not going to be using equipment grounds on circuits in order to create the equipotential bonding grid. You have to do something extra. Even if I have a non-conductive pool shell, like a vinyl liner pool or a fiberglass pool, that doesn't remove the fact that I still need the 3-foot perimeter around it. And it also doesn't remove the fact that any metal components that are within 5 feet of the pool still have to be bonded to that 3-foot equipotential bonding grid, okay? Whether I'm running the single conductor 8 gauge around the perimeter, 18 to 24 inches from the pool, or I'm putting in the 12 by 12 grid around the pool. However you do it, that is part of your equipotential bonding grid, and that becomes what everything connects to. All right. Now, where do I go from there? Do I take it back to your electrical panel? No, the code doesn't prohibit you from doing that, but why would you do that? Because you're not required to do that. That is not what that equipotential grid, that's not why you're bonding everything together. You're bonding everything together to reduce touch potential. You're not doing it to clear overcurrent protective devices. Okay? That's not why we're doing it. So what's the point in taking it back to the panel? The last damn thing I want to do is introduce anything from the electrical system onto that equipotential bonding grid because some whack job comes in later and improperly does something in the panel on a future job, and you did the pool, and now something happens and your pool gets freaking energized because you made one little mistake and you ran it back. Now, the code doesn't prohibit it. It just doesn't require you to do it. I'm telling you, as a guy that sits on code panel 17, do not take your equipment. Indirectly, they're going to be interconnected because of certain equipment like motors and things like that and bonding and all that. But you do not directly, I'm just telling you, I'm employing you. Do not go from your equipotential bonding grid and make an effort to take it back to any panel. Don't do that. Please, I'm employing you. You may never have an issue, but you may introduce something if a motor fails or something happens. You don't want that on your conscience, okay? Just don't do it. So remember, there's a difference between voltage gradient. There's a difference between equipotential bonding. There's a different function for equipment grounding conductors than what you're doing around the pool, tying all those metal parts together, okay? That doesn't remove the fact that you need equipment grounds to different things. But that is not the same as an equipotential bonding grid. Please, if you take anything away from that, take that away, okay? As Dave said, you know how many times I found ground rods driven to fix a pool bonding issue? I know, and it doesn't work. We know it doesn't work. We have data that was submitted to show that stuff like that doesn't work. Scary what you see, okay? All right, so there we go. All right, now, definitions. Key definitions that you need to take away from today, okay? And it's already, I can tell this is going to be multiple part series. I can already tell, folks. I can tell because of my ratchet jawing. But I think that you get more out of this type of conversation than for me just to go through the material. If you agree, give me a thumbs up. Give me a hell yeah. If you appreciate it. Yes, I'm long-winded. Yes, I'm going to get hate emails. Yes, I'm going to get negative posts on my videos saying, just get to the point, Paul. You talk too damn much. I know out there you guys are probably that follow me going, really? Do people send you that stuff? Yes, they do. They do. And I'm sitting there thinking, then you're the kind of person that doesn't need to watch my shit. I'm just saying, because I'm a long-winded, detailed guy. And you can always pause and watch later. You ain't got to sit through the whole damn thing unless you're on a live like today. All right, so let's look at some definitions. There are many one-of-a-kind terms that are used in 680. I agree 100%. So we need to look at these certain things here. These terms might seem like foreign language to many people that do not deal with pools, spas, and hot tubs. But you need to understand them, especially if you're going to dabble into it. And there is good money in pools and doing pools. If you're in Florida and maintaining pools, there are people I know that just make great money going out and repairing issues with electrical on pools. Maybe they're reading voltage. They're reading a voltage from the water. Okay, using a regular voltmeter, you can do it. Those type of things. So there's ways that you can mitigate it, and it's costly. But like David says, you're not going to mitigate that by just driving ground rods. I can promise you that. Is it maybe better than nothing? Yeah, maybe. But if you don't know how to do it, well, then you could probably make it worse. Remember what I said about grounding and bonding? Sometimes that type of scenario can make it worse. Okay. All right, anyway, so let's look at some of these terms, right? So we can make sense of it. The term corrosive environment. What is that? Yeah, well, it's areas or enclosures. And when we say enclosures, guys, we're not talking about enclosures like a panel enclosure that you put a panel board in. We're talking corrosive areas. It may be the area where the equipment is kept. It may be in an enclosure that has chemicals stored in there, pool handling chemicals, things like that, which causes inside of the actual enclosure in order to have the chemical presence, and it creates a corrosive environment. But it also could be anywhere that you have pool equipment, that you store chemicals, maybe your pool room. People say, well, in my pool room, Paul, that is not a corrosive environment. And I'm here to tell you the hell it ain't. If you actually take the chemical and put it into the chemical feeder, into the pool system, whether you incorporate it directly into the filter or you have what's called a chemical infuser, you're actually putting you're working in an area that's considered a corrosive environment. Now, what is so funny is that people like to say that you can't use PVC jacketed MC in those areas. And I'm here to tell you, you can. I'm here to tell you, you can. There will be other people out there saying, oh, no, you can't, Paul. I'm here to tell you, you can. Okay? They're full of crap because PVC jacketed MC has been evaluated to be installed in corrosive environments. If you go look at it, if we do PVC jacketed MC with conductors inside that are evaluated for wet location, you put them together and you go look at 330.12 and you meet all that criteria, then it is. People also think that you have to mark on the side of PVC jacketed MC that it is suitable for pool equipment. That is not true either. That is optional. That is optional in UL 1569. That is not a requirement for the manufacturer to put that on there. But most people, if they make a PVC jacketed MC just for that application, to avoid confusion, they might print that on there. But they don't have to. That is not required to be printed on there. Okay? The NEC doesn't require it for that type of scenario. Okay? So when you see something that says that a wiring method has to be evaluated for use in that location, Well, PVC jacketed MC is evaluated for use in a corrosive environment. We put it in the earth all the time. It's rated for direct burial. That's a corrosive environment. We don't know what's in the earth, okay? So at the end of the day, the way we wrote it, dealing with the corrosive environment and all the applications, I'm going to tell you that there is a list of things that they say you don't have to worry about, that they are okay for a corrosive environment, like rigid metal, things like that. PVC jacketed MC is evaluated for corrosive environment. It does not have to have anything on it that says swimming pool. There is no evaluation for that. Just like there's no evaluation for rigid metal, intermediate metal, things like that. But it's okay to use it, right? And also you have to remember, almost all of the damn pool equipment that's in a pool room is what? Plastic. Common sense, folks, right? Anyway, I went on a little tirade, but let me get back real quick. Probably because I have to answer that question so many damn times. All right, so corrosive environments is the area or enclosure without adequate ventilation. You could have adequate ventilation that an AHJ might determine that an area is not considered a corrosive environment because of the number of air exchanges. Now, we don't have that in the NEC. I think we tried to submit that, or I think I submitted that to do the same thing as a hazardous location. If you have like a pit and you have 4 exchanges per hour, and that you can remove it from a rating down to an unclassified rating or something like that, we could have had that as well. So if you have a number of air exchanges that remove all of this, then you may have an AHJ that will say, you know what? I don't consider this a corrosive environment. That's the beautiful thing about the AHJ. I mean, they're the ones, the boots on the ground. David, they get to make the decision. But it has to be comfortable enough if there is adequate ventilation. Okay, so again, this is directly out of the code. Okay. So areas of enclosed without adequate ventilation where electrical equipment is located and pool sanitation chemicals are stored, handled, or dispensed into the actual system. I could have a separate shed. Separate shed could have all the chemicals in it. Okay, that's a corrosive environment, but I'm probably not going to have anything out there, right? That type of thing. So it's just a somewhere to store the chemicals or something like that. All right, but that's what a corrosive environment is, okay? Approval of equipment, 680.6. These are just ones that we want to really focus in on. The National Electrical Code, approval of equipment. All electrical equipment covered by this article shall be listed. So important. So .6 is a listing requirement. It's requiring that all equipment, the pumps, the filtration system, if it connects to the electrical system, all of that type of stuff has to be approved. Okay, so it has to be listed. It has to be evaluated. Okay, that type thing. So if it is, it's going to be for this amount. It's going to say on it that it was listed for use in a pool and spa type of application. Then it's okay. Then we can use it. All right. This one right here is one that would cause a nightmare for many places. Okay, and I'll highlight this because this one has or will or could. And a very overzealous jurisdiction could possibly use this improperly, but I do need to explain this. So we incorporated this into the code. It says 680.4. It's called inspection after installation. Okay. Now it says while it is, you're going to get your inspections, right? So what's the process? You go get your permits. You're the electrical guy. You get the permits, the pool contractor gets all their permits, make sure everything's good, there's setbacks and whatnot. They start doing the pool, they start framing it out. They get all, if it's a gunite pool, they start putting in all the frame structures so that they can pump the gunite into it. Basically a concrete mixture. They pump it all in it. They get all the wet niches if you have them or anything. They get all this set up and everything done. And then they call the electrician. The electrician comes out, and that's where you're going to start doing your equipotential bonding grid, tying everything. If there's metal ladders, tying it all to the grid, tying it, making sure you get your equipotential bonding grid in place before they pour the walkway around it. Look for any metal things that are within 5 feet of the pool that you're going to have to bond. All these type of things. You're looking around for all this. Do I have any luminaires that are too close or whatever I got to do? all those type of things. You get your inspections. They come and they pour it. Everything's good. And then you come back and then you'll hook up everything that may be the pumps and the power to the pumps and all that kind of stuff. Okay, so you do it in pieces. You get those inspections, right? It's a step-by-step process. Now, while it is unusual for the NEC to create a rule that allows for periodic inspections after a project is completed, very rare for the NEC to do this, right? Once you get that inspection done, they never come back in your house again. They never come again, right? Well, this was introduced. And again, every jurisdiction is going to treat this differently. But there is now a requirement in the code. And it says that it's periodic inspections after the project completed. It says the NEC rule will permit the AHJ to conduct periodic inspections and subsequent testing after the completion of the project. Now, with that one, I have got to take you to NEC because I did have a guy one time and I said this. He said, Paul, that just can't be accurate. Yeah, it is in there, right? I argued against this one, by the way, because I just don't see how jurisdictions are going to do this. But here you go. Inspections after the installation. It is in the code. It says the authority having jurisdiction shall be permitted, not required, permitted. So that means that typically to do this, a local jurisdiction will create a rule or create a permitting fee or maybe they'll do an annual inspection fee. It's a money generator, David. Don't give your jurisdiction any ideas, okay? Where they're going to send out to everybody that has a pool, right? Because supposedly everybody that has a pool got permits. So they should have records somewhere. So now they're going, you know what? We know that there's aging pools. We know that there's pools that have been around that probably don't have the equipotential bonding grid, that were done improperly, that pole pumps are just gone to crap. There's so much jacklegging going on. You know what we're going to do? You know what we're going to do? We're going to create an ordinance for my city. And we've adopted the NEC. We adopted 2023. And what we're going to do, and this isn't new, by the way. This was in the 2020, I believe. So they're going to say, look, here's what we're going to do. Here's what we're going to do. We're going to charge you $100, and you have to do that annually. You have to get your pool inspected. So they're going to hire 4 guys. This will fund itself. It'll fund itself, right? It depends. If you don't have any chemicals, David, I don't know how it can be the whole definition of corrosive environment, right, was area closures without adequate ventilation where electric is located and pool sanitation chemicals, because it says and, chemicals are stored, handled, or dispensed. If there's no pool chemicals, then I don't know how it can be a hazardous location. A corrosive, not a hazardous location, I'm sorry. A corrosive environment. If there's no chemicals in the water, then I don't know how it can be a corrosive environment. I don't know how it could be. You get what I'm saying? So best I can tell you on that one, David. I don't think so. If there's salts, is salt considered a corrosive? Is it considered a chemical? I don't know. You're going to have to talk to AHJ. David's the AHJ down in one of the AHJs down in Florida. David, do you think salt is considered a corrosive environment? I don't think salt gives off things unless it gets wet, that type of thing. So again, some people may consider that. Check with your local AHJ. I'm not going to be the one. I'm not an expert in salt. I know that any of the other chemicals are because of their caustic and what they do. Salt can corrode things, and the salt is used to emitting. So, somebody may consider salt a corrosive material when it comes to that. Err on the side of caution, because a lot of people, I can tell you from my brother's experience, he went from a chemical pool, transitioned to a salt water treatment system, and he went back to chemical, right? Yeah, David's salt in the air seems corrosive to David, so there you go. But my brother went back. So personally, I would err on the side of corrosive and make sure I followed the rules, because I can tell you my brother did go from chemical to salt. For some reason, he did not like the salt treatment system. He went back, and I think it's because the salt actually was more detrimental to some of the components, metal parts of the pool, than the chemical was. So he ended up going back anyway for longevity of his pool components. So yeah, I'll go on the record. I will say, yeah, I'll go on and somebody will tell me I'm wrong. I'll get an email, okay? So salt is considered corrosive. Google. There you go. Somebody asked Trade Hog. They'll probably know. So yeah, I'll go on and call salt. I guess, yeah. I don't remember us ever discussing this at the code panel. So it might be an interesting conversation. But yeah, okay. I'll consider that a chemical. It's salt. Okay. There you go. So yeah, it's corrosive. Answer your question. I'm going to stick with that. All right. So anyway, we're back here to do that. And it says, okay, so that is going to allow them to do periodic inspection and testing. Maybe testing to make sure that you have an equipotential bonding grid in place. That type of thing. So yeah, okay. Oh yeah, David says from the hurricane, the power lines and all this kind of stuff. So yeah, salt water. Yeah, okay, so we'll go on the record. Maybe I'm just having a brain fart today. I don't remember us discussing that ever at a code panel. But yeah, there you go. It's salt. And it may even say something under that. Let's go real quick. Let's go look. Because I'm over time anyway. Let me go real quick and look at something real quick. Because I could have just a brain fart. Let's see here. Let's go look real quick. Corrosive environments. Let's go look. Let's look right here. It's probably there and I just didn't hear. So here's corrosive environment. Let's see. Let's go back here first to... Hold on. Let's go back right. Let's see. Hold on here. Let's see. Now, okay. Let's go. Let me go back to where I was. Sorry about that. I'm in the 2023, folks, by those that happen to answer. Okay. Let's go. Let me go right here. Okay. Corrosive environments. Wiring methods shall be suitable for use in corrosive environments. I'm going to tell you, PVC jacketed MC is. Okay. Then it says rigid metal intermediate, rigid polyvinyl chloride conduit. Okay. PVC, by the way. Hello. Anyway, yeah, I won't go down that rabbit hole. There you go. Right. So now, there you go. So it's not specific. But let's see here. I was hoping that I had something else, and I couldn't remember anything else. I thought maybe there was a something as a drop down, but I don't see the drop down. I thought we had some explanatory extra commentary. I thought that they provided some commentary in here at some point, but I don't see it. So. This is link, by the way. I don't see any extra commentary. So anyway, so no additional commentary. So yeah, we're going to go with salt is. So again, a jurisdiction could invoke periodic inspection and charge you for it. Okay. Now, again, I think that, we got private properties and going into people's properties. It's not an active permit anymore. I mean, there can be some legal involved with this. Okay, so it seems to me like your jurisdiction would have to create a plan or a program, but they have the ability to do it and then charge you a fee for it and then reach out to everybody, right? And then tell them that they're going to be charged a fee. I can see them doing that. Hope it doesn't happen in your jurisdiction, right? Okay. Let's see. Jack, All Day Jack says, can you be compelled to install a bonding grid to a pool installed when not required? You're going to have a bonding grid at all pools. If you don't have a conductive pool shell, which means what holds the water, if it's not rebar in concrete in contact with the earth, if it's not a concrete that's contact with the earth with the rebar, if it's, let's say then you've got to have it. Okay. If it's vinyl or it's a fiberglass, you're still required to have the bonding grid, but it's the perimeter bonding grid. It's the around the perimeter of the pool. That's still required to do that. Okay. Whether it's grass or whether or not you use pavers or you do concrete, still got to have some form of equipotential bonding grid involved on it. Okay. The only difference is that if you have a conductive pool shell, concrete and rebar, whatever, it's in contact with the earth, right? Or if you have a conductive pool shell that's concrete, no rebar, and you use the metal grid underneath it, like 12 by 12 copper mesh that wraps under the pool, that is an acceptable method. That's a costly method. I don't know why you'd want to do that, but you know, it's copper, so whatever. But you could go under and do it. Then in that scenario, if it's concrete in contact with the earth, concrete, whether it's plaster or whatnot, is considered porous. And so it's a conductive component. Okay, it's going to allow porosity of water to move through it. And of course, earth is on the other side, right? That type of thing. Okay, that type of thing. So, all right. So, all right. So let's see here. Well, we're not that far yet. So let's go back to the code. Where are we at? All right. So here we go. All right. So yeah, you're going to have a conductive pool shell. Now that would be for if you're talking about a above ground pool. We have to get into that code. We'll get there when we look at the code and in that scenario. But typically, most all pools above grade, below grade, still going to have some form of equipotential bonding requirement around the pool, that type of thing. All right, see what other terminology? Okay, ground fault circuit interrupter, not new to everybody. Everybody knows what that is, 680.5. So GFCIs, and we're going to look extensively at 680.26 when it comes to the equipotential bonding grid, so I don't want to go too quickly too far. So GFCIs are required. Y'all are way too far ahead, guys. Slow down. We're not there yet. I know you want it all in one episode, but obviously we're going to do equipotential bonding. We're not there yet. I get it. So keep those questions. So GFCIs are required, because I want you focused on what we're talking about. GFCIs are required to be listed. Circuit breakers or receptacles or other types, listed types. GFCIs are discussed in Chapter 6 of our program or in the residential program. You won't have it because this residential program is not available anymore. But y'all know what GFCIs are. We've talked about them, how they work. Class A, these are the ones you'd use, 4 to 6 milliamps. They're not going to activate at 4 milliamps or less, but they will activate at 6 milliamps or more. We use 5 as a nominal because it allows for variations within the different manufacturers, but that's what they're shooting for, a 5 milliamp nominal. Okay. Although Article 680, you will find the requirements for GFCIs in addition to GFCI. Article 680 uses the term special purpose ground fault circuit interrupter. Okay, so we introduced something called special purpose. Okay, so what's a special purpose GFCI? It's a device intended for detection of ground fault currents used in circuits with voltages to ground greater than 150 volts. Okay, so if you have voltage to ground, you have the normal GFCIs, Class A, which typically 120 volt type of applications. To ground. Here is for those that are greater than 150 volts, okay? And that function to de-energize a circuit or portion of a circuit within an established period of time when a ground fault current exceeds the values established in a Class C, D, or E device. So you have Class A and Class B. Class A is the everyday GFCI that you would use in your house. That's what you're going to use around the pool, right? And then you have a Class B, which is usually typically 20 or 30 milliamps. It's not the same. It's not for personal protection. It's more equipment protection, although it can protect you because it is still below certain volatile thresholds, but it's not the same as the direct personal protection of a Class A. But you do have B, and they're typically used on things like snow melting applications because they don't nuisance trip as much. And of course, then you also have C, D, and E, and typically those are the ones you're going to see on higher voltage class GFCIs, 240 volt ones, 277, 480. If you have GFCIs for commercial applications, you're going to start to see higher classes, all right? And they're going to have a certain period of time where the actual GFCI function will trip based on the different classes and based on the different use, okay? But not what we're going to use for everyday pools, spas, and hot tub. That's going to be a Class A type of GFCI device. That's what we're going to be using, okay? It also says, keep in mind that all of the GFCI requirements that can be found in Article 680 are either in addition to or they modify in some form all of the ones that are listed in 210.8. So 210.8, there's an A and a B. A for dwellings, B for other than dwellings, okay? So in 210.8A talks about receptacles, right? In the GFCI protection for receptacles. Anything that gets added here in 680 is in addition to whatever's in 210. This is in addition, okay? Extra, okay? Remember the rules in the code, the how the structure works? Chapters 1 through 4 apply broadly to everything. 5, 6, and 7 will modify and supplement anything in chapter 1 through 7. We're in what? We're in chapter 6 because this is 680. So it is serving as to supplement or modify something that is in chapter 2, right? Which is 210 for GFCIs. So that's how it works, in case you want to know how those functions work. So it's changing it. So it's in addition to whatever you are already required to do in 210.8. This is something extra, a little something, something, okay? Same with the equipotential bonding, okay? You've got your grounding, 250. This is extra. This is in addition to all those requirements. So that's how the code works, okay? It says it's important to ensure that all installations must meet the provisions found in 210.8 GFCI for protection of personnel, in addition to those referenced in 680, okay? Now be careful when connecting underwater luminaires, okay? And this is funny because my son who does pool applications contacted me yesterday and asked me a code question. Because he threatened to kill me in the past, I chose not to answer him, which he proceeded to tell me to go to where, and that he hates me because I wouldn't help him. At the end of the day, he said, I'll just pay somebody. I told him, I said, call Mike Holt. He'll help you. So at the end of the day, it's so important to understand that his question to me was a very serious safety concern. And did I feel compelled to help him? No. When you tell me you want to kill me, I'm not going to help you. But at the end of the day, it's so important with the underwater luminaires because you're actually putting the luminaire down in the water, and whether it's wet niche, dry niche, or no niche, you're putting it down into the water. Any malfunction could potentially energize the water, right? Okay, so look, once you run conductors beyond, we're talking about the load side of a GFCI device, protecting that wiring, you are not permitted to have other conductors in the same raceway, box, or enclosure. The exceptions to this rule apply when other conductors are protected by GFCI. So most of them is, say, for example, let me give you an example, a pool box. Typically a pool box that's going to supply down to the wet niches, let's say, which typically have a cord on them that come up through the raceway, up to the actual box where you're going to make the connections. You are going to have raceways with other circuits in there, right? Other conductors in there, but typically they're all going to be GFCI protected, okay? So that's one of the exceptions. The other conductors are equipment grounding conductors. Obviously, they can run in the same raceway, okay, with those circuits that are GFCI protected, right? The other conductors are supply conductors to a feed through GFCI, okay? That a feed through GFCI, the typical ones that come in and they go right out through it, normal receptacle. But you also have the type of GFCIs that have no receptacle on it, right? They just simply are a faceless. They feed through too. They have those as well. In case you didn't know, they make those as well. And it says the GFCI is installed in a panel board where obviously there will be mixing of other circuits. So this is a receptacle that is integral to maybe a pool panel. And maybe they're putting the receptacle in there for the convenience, that type of thing. So it's integrated into it, all right? Okay, just kind of those are areas. So other than that, the general rule is you're not going to have other circuit conductors inside on the load side of that GFCI that's protecting everything downstream with GFCI. You're going to have no other conductors in that raceway, box, or enclosure unless it meets some of this criteria. Good news about that is it's really a no-brainer. I mean, if you're running GFCI for the pool lighting, for example, which is typically what you're going to do, the pool pump and all that, that's remote. That's somewhere else. You're typically the only time that you'd struggle with this if you're running raceways out to do things like the wet niches and the lighting that goes in there or something like that. Well, all of those are already going to be GFCI protected. So it's kind of handles itself, but you need to understand these things, okay? All right, so this is what we're talking about right here, see? So GFCI requirements, and this is why it made reference right here. This is covered in 680.23F3, but it's kind of showing you what the illustration looks like, okay? So I read you this, but that's where it says. So here it is right here. So GFCI requirements for branch circuit that supply underwater luminaires, okay? So it's coming out of this panel here, and so here's the breaker right here. Oops, hold on. So there's the breaker right here. I know this is hard to see. I don't know if I can blow this up. A little bit better. So here's this going out. So let's see here. So this is a GFCI protected conductors permitted in the panel. So these right here to pool pumps or other non-GFCI protected circuits. Okay, right here. All right, they're inside of this panel. That's fine. You're intermixing. Not an issue, right? This goes from here, goes out to underwater lights. Only GFCI protected conductors are permitted in this raceway. Makes sense? That's what it's going out to. And it's going out to the lighting, okay? Now, there's a high probability that, folks, that this is probably going out to a pool box, a pool junction box that's near the pool, right? In order to drop out of it and go down to your luminaires. That's a high probability where that's going from, depending on where this panel is located. Here, supply conductors are permitted to GFCI devices. So here it's coming down here. And this is coming, if you look at it, it's coming from standard breaker right here, coming out, coming down, right into here. So supply conductors permitted to a GFCI device, not in a raceway on the load side of GFCIs if conductors supply underwater lighting. So these that are coming out of here, nothing else can go into this, okay, except for if this is going to the underwater lighting. That's all that can be in there because it's on the load side of this GFCI coming out, okay? Makes sense? All right, let me see if I can, let me try to get it back to where it makes sense on the screen. That isn't it. All right, that's probably better, okay? All right. All right, what about 680.7? Okay, you're going to run into this. So this is the grounding, bonding and grounding of equipment. Now, this is in .7, but it is very important because here's what it says. It says, in general, grounding of equipment is required to be done as required in 250. So you're still going to follow your grounding and your bonding rules. You're still going to follow tying your equipment grounds, bonding everything, the boxes. You do everything as normal, okay? It goes on to say this section now states that electrical equipment shall meet the equipment grounding requirements in Part 6 and Part 7 of Article 250. But there are modifications that specifically address swimming pools also right here in 680 that you have to be aware of. So now all it does is in 680.7 is that it just reminds you that it says right here, okay, 680.7. And I wanted to come here because you see that in the 2023, it's a little broader than just the definition or just an explanation. Here, you've got grounding and bonding, right? And if you're doing with feeders and branch circuits, what does it say? It says feeders, and you may be going from a panel to a swimming pool panel. That would be the feeder. So feeder and branch circuits installed in corrosive environments or wet locations outside. Okay, so in their mind, they have to say wet location, which I have argued for years, like, does it make an outdoor wet location always a corrosive environment? And now it doesn't matter. It is, I would say, well, can rain be acid rain? Could it be corrosive? Does water cause corrosive condition and all that kind of stuff? Yeah, maybe, but now it doesn't matter. It says if you install the feeder or branch circuits, the circuit itself is installed in a corrosive environment, maybe where you're storing your pool chemicals, wherever that type of thing, or maybe under a decking system where you store your pool chemicals. That would be the area, by the way. Or in wet locations, shall contain an equipment grounding conductor that is insulated copper. Okay? Sorry about that, aluminum lovers. It's got to be copper, and it has got to be insulated. No bare, okay, in this application for this feeder or branch circuit. If it's in corrosive environments, not the same if it's not a corrosive environment, okay? It's just for in corrosive environments, okay? And it has, if it is a corrosive environment or outdoors, in most pools and panels and branch circuits and all that for pools and all that will be outdoors, okay, generally. So that type of thing. It is required to be insulated if it's in those conditions. And it has to be sized in accordance with table 250.122, obviously based on the overcurrent. Don't get me started, David. I don't see that type of material right here. You want to get me in trouble. It's what David wants to do. He wants to get me in trouble. I'm not going to do it. So copper only, baby, right here. And you size it based on 251.22, but in no case can that EGC be smaller than a 12. Okay. And this is an example right here, just kind of looking at the picture. This is a corrosive environment. Here's where the pump is. Here's where you're going to be adding the chemicals inside of here. It's considered a corrosive environment. Okay. And you got a panel in here, yada, yada, yada. Okay. And here's the feeder coming in, putting this panel in this pool house. One of the things that I will tell you that came to light, and I'm going to tell you this was funny. And it is changed for the code now for like things like luminaires. But here's what's funny. When they were arguing that PVC jacketed MC could not be in that room, in that picture I showed you, couldn't be in there, they said, no, it's not corrosive environment. You know, it's not evaluated for... I laughed because it's got a PVC jacket. PV is very resistant to corrosion. Hell, you're allowed to use regular PVC in there, and that will dry out and crack because it doesn't have plasticizer in it to make it pliable. Or the pool pump equipment's probably plastic anyway. So what's it matter, right? But they didn't want PVC jacketed MC in there. Even if you use proper listed fittings and it like a polyolefin and it overlaps the PVC sheathing that is extruded over the... They're like, no, you can't have it. This was so funny. And it was the NEMA folks at that point, they were arguing against me, right? One of their NEMA representatives. This guy's name was Marcelo. Nice guy, but he was arguing against it, right? And I looked at him, and they were all arguing that, no, you can't have that in there. And I looked at him, and I went, okay, so you don't want PVC jacketed MC in there, which is evaluated for use in direct burial where marked, and PVC is very corrosive resistance, and we have the rules in 330.12, the use is not permitted, and in the allowance for the construction that would be allowed. Okay, I hear you. And we have no testing for rigid for these locations or intermediate, and the code says that PVC can be used in those environments. Yeah, I got you. But you won't let me use PVC. Did you know that the breakers that are in those panels that you will allow in those locations are made of plastic, sir? Did you know that a lot of those panels that are located have possibly aluminum buses? Most of them are going to be copper or silver coated or zinc coated or some other coating on them. I'm like, but you have other components in there that could be corrosive. You have metal screws that might be steel. I'm like, do you really think that the hazards from a product that's allowed to be directly placed into the earth and evaluated for that is really where you want to have your fight? Is that really where you want to fight? And so I started bringing up, I said, well, what about the lights? What about the lights? There's plastic components on the lights. Are you going to make the lights be special in the room? Are we going to have to install special panels in the room? Are they got to be sealed like a damn hazardous location? Be careful what you ask for, Mr. NEMA guy. Because if you ask for it, you will get it, right? So then they just kind of backed off, But I mean, again, I always say a good argument, be careful what you ask for, right? So in this scenario right here, a panel is installed in here, okay? And this is a structure, right? This is a structure that is built. So this is why you see a grounding electrode conductor here, because this is a structure. They put a panel in it. So remember, we're required to establish a grounding electrode system out here. So they did it, okay? It's a detached structure being fed by a feeder, right? You just got to be careful, that type of thing, because this is a corrosive environment. Right now, in this feeder right here, because this is a corrosive environment, because this feeder is coming up into it, then the feeder from the service with an insulated copper equipment grounding conductor run with the circuit conductors, that requires it to be insulated copper, okay? Make sense? I hope that makes sense. Okay. Oh, I wasn't done. Dude, I got so much more on this topic. Let me take you back real quick. So that was that. So then you also see the new here. These are new, right? All this kind of new, the way this was constructed in the 2023 edition of the NEC. So that was just for the feeder and branch circuit. What about cord and plug connections? Well, it says flexible cords shall contain. So if you have some piece of equipment in there that's got a flexible cord, it says the flexible cord shall contain an EGC, that is insulated copper conductor, size in accordance with 250.122, but not smaller than 12. So again, easy to remember those things. EGC is a minimum of 12, and it's insulated, and it's copper, okay? And it says the flexible cord shall terminate in a grounding type attachment plug having a fixed grounding contact member or a fixed grounding point, okay, on the attachment plug, okay? And of course, you have terminals. It says terminals used for bonding of equipment and equipment grounding shall be identified for the use in wet locations. Most of the people that make the pool equipment will already take care of this. The terminations that they provide for bonding and grounding and all that will be well documented in the literature. Don't worry about that. These pool folks are, they're very keen on those type of things, all right? So they're all very keen on this type of scenario, okay? All right, so bringing you back to the lesson, and we did talk about that here, by the way, because here's the one for the terminals, right? And so we do give you the code reference. So I really didn't need to go to the code. I kind of forgot that it was already in here. My bad. Yeah, David. Yes, David. None of that in there. All right, so terminals used for bonding. We already read that. Now, such conductors that are identified for being suitable for direct burial are also suitable for concrete encasement without additional markings to indicate their permitted usage. That's an important one for you, David, right? So all these terminals, as they're connected to the various equipment, those such connectors that are identified for direct burial are also suitable for concrete encasement without any additional markings, okay? So when we're using the different terminals to connect together, to interconnect the equipotential bonding grid, things like that, all of those types of fittings, if they're rated for direct burial application, then they're also going to be suitable for concrete encasement. Now, most manufacturers are probably going to have that somewhere buried in the literature as well. But again, if you're going to be using them, for example, to make connections to the equipotential bonding grid and all that, and they're listed for direct burial, there you go. The only thing you have to be careful is if there is a specific fitting that only can be used on a certain application, like only for rebar and not for, let's say, ground rods or something. You have to be careful on those type of things. But generally, most of these folks, there you go. I know you are, and I'm on there as well. We're both on 486. You're just probably way more active than I am on UL 486. I can promise you that. I am not very active, David. I probably should be, but I'm not. Let's see here. All right, there was the cord plug. We already read that. Okay, so then you permit, we have to find permission to use flexible cords for fixed or stationary equipment associated with permanently installed pools. Okay, and it says underwater luminaires are not included in this permission. Okay. All right. Typically, the underwater pool luminaires have their own cord that comes up as part of the listing when it comes to those like wet niches that go inside of the wet niche and the cord comes up and into it. They'll have their own equipment ground and everything associated with that. Okay. All right, the next you have to be aware of is 680.90. These are one of the things that you need to keenly be aware of. Now, hopefully, whoever's designing the pool, whoever's looking to where it goes, where you're going to be dropping it in somebody's property, hopefully they are very aware of what's above them, right? They are very aware of what's near them. So when we're talking about overhead conductors, right? 680.9, it says overhead open conductors must be kept out of reach. Okay. Specific clearances are provided for power, communication, and network-powered broadband communication systems. Network-powered is a little different than premise-powered. So network-powered, it's telling you it's coming from some power from outside of the premise. Okay, whether it's generated from the communications company or whatever that's coming in, that would be what's called a network-powered. Premise-powered broadband is something that you might power from internal inside the building and things like that. Okay, so we have all these clearances that we have to follow, and there's a table for that. Okay, and if you go over into the code, here's your clearances right here. Okay, and you'll see for power we have A, right, and it's going to reference this table right here. Okay, and then you have communication. Okay, it's going to have its own requirements right here, right? And then you've got network-powered broadband and minimum clearances for overhead network-powered broadband systems for pools or fountains. Okay, so pools or fountains shall comply with the provisions of Table 680.90A for conductors operating 0 to 750 volts to ground. So it's going to reference you back to this table. Okay, it's going to reference you back here. If you're dealing with communication, coaxial, things like that are coming down, it says communications, radio, and television coaxial cables within the scope of Chapter 8, because that's what covers those things, okay, shall be permitted at a height not less than 10 feet above the maximum water level of a swimming pool or wading pool. Maximum water level, by the way, is the point where it's going to spill out over top of the pool. Okay, that's the ability. The highest the water can go is the maximum water level. Okay. All right. So again, so this is at 10 feet. So above the maximum water level of the swimming pool and wading pools and diving structure, observation stands, towers, and platforms, that type of thing. So 10 feet. So just as an example, you're looking at things like this. So here you see they're just kind of showing you this layout. This right here is for this. Okay. So when it comes to communication, just remember it's got to clear 10 feet in all directions. Okay, when it comes to the communication systems. When it comes to the network-powered broadband, refer to the table. When it comes to power conductors that are coming down, let's say from a utility transformer and things like that, then you're going to refer to the table. Pretty straightforward, right? I always tell people when I'm there and I'm doing a pool or I've been involved in pools, I always do it. I just go look and say, where the hell is this pool going? Then I go look around and go, are there any damn utility lines near me? Because that's the last thing that I want to do. And how many times have you done something like that, right? I always tell this, when I go into a place where I'm worried, everybody's always looking ahead, and I'm always looking ahead, I'm looking down, and then I always remember to look up. You never know what the hell's up there, right? I go to those haunted houses and stuff, everybody's looking ahead. I'm not, I'm like, I can't help it, right? Because people get so tunnel visioned, they go dig in a pool, they don't think about it, and the next thing you know, they got utility lines, or they got the service drop coming to the house because they got limited space in the property. It's better to find these things out now than after you start breaking ground. I'm just saying, okay? So be aware of that. All right. Next thing we want to be familiar with is electric pool water heaters. Okay. So 680.10, all electric pool water heaters. We're not talking gas here. We're talking electric pool water heaters are required to have their heating elements subdivided to separate loads not exceeding 48 amps. Okay. So they might have separate supplies to it or segregated out. Okay, so that the loading is not to exceed 48 amps on each set or bundle of heating elements, okay? and protect it at not over 60 amps. Low-hanging fruit on an electrical exam is that just remember that the electric pool water heaters, if you so have one, okay, again, you're going to be burning some, you're going to be using some serious electrons to do an electric pool water heater. If you don't have gas, it might be your only option, or unless you live somewhere that you don't need it. I don't know. In Florida, David, do they put pool water heaters on there? That type of thing? I would think it's, for the most part, it's warm enough down there you wouldn't need it. But if they do have the heated water and it's electric, then you have to subdivide the heating elements so that none of them are exceeding 48 amps. And it's protected by not over 60 amps. That's a low-hanging fruit on an exam, right? Okay. But y'all are spoiled down in Florida. You always have to have that nice warm water. Okay. All right. So the branch circuit conductor ampacity and the rating of the branch circuit overcurrent devices must not be less than 125% of the total nameplate rating, ampere rating for the electric heater. So this is an example where it's a nameplate rating. All right. So let's go look at the code real quick. And right here. So see these new, right? New, all right? New thing. This is why it's so important for you to stay up on the code, folks. Changes. I don't know. Florida, y'all are still 2020, right? I don't think y'all have gone to the 2023 yet, okay? Yeah, Arizona, okay. Arizona has a heater too. They're spoiled in Arizona too, Charlie. All right, so you see here, it used to be just electric pool water heaters, and now it's been revised. It adds all this extra language in it because it also added electrically powered swimming pool heat pumps and chillers, okay? So it gives you some direction on how to deal with those, okay? So what about those heat pumps, okay? Those type of thing. Well, it says electrically powered. That was probably the more efficient way to do it, guys, would be electrically powered pool heat pump. That's probably the better choice, but it probably costs, it probably costs you more to use the electric one than it would be to use an electrically powered pool heat pump model. And maybe that's probably what most of you have, by the way. All right, so anyway, electrically powered pool heat pumps and chillers used using the circulating water system to provide heating, cooling, or both shall be listed. Okay, so it's got to be listed for this application for use with pools. Okay, makes sense. And rated for their intended use. Their intended use is to supply heat to a pool. Makes sense. Or I guess could cool a pool, I reckon. All right, so it says the ampacity of the branch circuit conductors and the rating or settings of overcurrent protective devices shall be sized to comply with the nameplate. So you just follow the nameplate on these, which is kind of going to probably be like a heat pump. It's going to give you all the information on the nameplate, right? So down here with electric one, it was very specific. The ampacity of the branch circuit is going to be based on 125% of the nameplate rated load. So on that nameplate, you're going to look for the rated load. Can it be greater than that? Absolutely, it could be. But it has to be at least the 125% of the nameplate's, quote, rated load, okay, on this water heater, okay? All right, let's get back to our lesson. Boy, we're unpacking a lot of stuff today. All right, let's talk about those underground wiring locations. Okay, so this is underground wiring locations. So this is 680.11. Now, we used to have this little chart, right, in there and all this kind of stuff that we had. And so, again, it's simplified a little bit now when it comes to the NEC. And we'll go look at it. But we're talking about underground wiring locations. It says underground wiring is not permitted under the pool. So yeah, you don't want to take your wiring under the pool unless you have some pool that's got equipment that it's necessary to get under the pool. I don't know why you would, but if there's something underneath them, dude, y'all are going all the way to 2027 before you're going to adopt the 2023. Y'all sound like Virginia, bro. What's wrong? Aren't you involved in that stuff down there? Don't you get Brian Holland? Y'all need to get Florida to change quicker. Come on, bro. Get them on the code quicker. All right, so unless it's necessary for something that is under the pool, It doesn't mean that you go under the pool to get to a piece of equipment on the other side of the pool. That's not what it's talking about. If it's something that is installed or has to be under the pool that it makes it necessary that you have to put the wiring under pool, then you can do so. Other than that, you do not route the wiring methods under the pool, okay? Also, be honest with you, it makes a lot of sense too. Unless something is designed to be under the pool that you're powering, other than that, why would you do that, really, okay? All right, so underground wiring locations, unless necessary. However, the following wiring methods are permitted to be installed underground within 5 foot horizontally from the inside wall of the pool, okay? So typically it used to be you don't do anything within 5 foot of the perimeter of the pool. You had to route your wiring methods away from it. Now I'm going to let you install within 5 feet of the pool. I'm going to let you run wiring methods now in that 5 feet, okay? But they have to be certain types, okay? So let's look at it. So here it says, all right, well, I will let you now route your, whatever you're running those raceways for, or cables for, whatever you're doing it for, I'm going to let you do that, all right, within that 5 feet, okay? If it's not in this list and you want to use some wiring method that is okay for direct burial, but it's not here, then you have to make sure you stay 5 feet away from the pool perimeter. Does that make sense? Okay. So rigid metal, RMC, IMC, intermediate metal conduit, rigid polyvinyl chloride conduit, PVC, reinforced thermoset resin conduit. I don't know if any of you have ever worked with this stuff right here. Dude, this stuff is, first of all, it's all the gluing and how you have to do it, but this stuff is amazingly strong stuff. It's incredibly strong. Jacketed type MC that is listed for direct burial. Okay. My most favorite. Liquid tight flexible non-metallic conduit listed for direct burial. Liquid tight flexible metal conduit listed for direct burial. So as long as it's got that DB printed on the side or DB use or rated for DB use or however it is marked on the side of it, then it can be installed within that 5 feet. Now, it used to be that you had a depth of cover. So how deep it had to be. So how much cover you had over top of these wiring methods. It used to be that in 680.11, you had your own little chart that was different than 300.5, which is our normal direct burial depth of cover requirements, right? It's for all general applications that are underground, right? Well, there was a separate table that was here in 680.11. Well, good news, it's gone. It's not there. We don't have a table anymore. So that means that what do you use for the depth of cover for these wiring methods that are permitted within that 5 feet? Well, you just follow the same rules that are in 300.5. Same depth of cover rules apply. It's not brain surgery. You don't have two different tables to get confused with. Just follow the rules in 300.5 and you'll be done with it, okay? And where this got confusing for people is because people would run wiring methods to get to that 5 foot area to maybe a piece of equipment that's in there. And it had to meet the requirements of 300.5 outside of that 5 foot area. Then when they got into that 5 foot area around the pool, then they had a different depth requirement. Well, it made sense, right? Because you have to get up to the equipment, right? So there was a reduction. It just caused confusion. Well, it's not confusing anymore. The depth of cover in 300.5 is still what you're going to use, that type of thing. But you have specific wiring methods that are allowed to be in that location. And here you go. You're listed right here. Okay. So we're not, not reinventing the wheel here. Now, there is a caveat, and I think it's extremely important in the 2023 edition of the NEC, is this caveat right here. So these wiring methods can be within that 5 feet of the pool. Okay. It says the following wire methods shall be considered suitable for the conditions in these locations, provided they are installed complete between between outlets, junctions, and splice points. We're not talking sleeving. We're not taking one wiring method and sleeving it in this 5 foot in order to be able to use a wiring method that's not listed here, but sleeving it so that I can have it within this 5 foot. It has to be complete from point A to point B to be in this within this 5 feet. Okay, as long as it's in one of these types of wiring methods. Okay, right here, one of these wiring methods. Okay, makes sense. So that is under pull wire, and then again here. This is what I read earlier. This is the under pool wiring. It's in you can have wiring under the pool. Okay, it says it shall not permitted under the pool unless that wiring is necessary to supply pool equipment permitted by this article. Okay. All right, so let's get back to the lesson. All right, there we go. All right, so what about equipment rooms and pits? So this is new for the 2023 NEC. Okay, it says electrical equipment is not permitted to be installed in rooms or pits that do not have drainage to prevent water accumulating during normal operation or filter maintenance. Equipment is required to be suitable for the environment in accordance with 300.6, again, corrosive environments, those things like that. Where it's located, wet location, all those good stuff. It says extensive information and requirements on corrosive and deterioration is provided in this section. Okay, that's 300.6, by the way. There's a lot of good information there about corrosive environments and things like that. It says at least, now here's important, at least one GFCI protected receptacle outlet rated 15 or 20 amperes, your choice, is required to be located within an equipment room. So this is just for the equipment room. Wasn't required to have one before in the equipment room. Okay, this is new. It's been added. I will take you to the code. So here is, again, this was the drainage requirement. Okay, so got to have drainage. Again, I will tell you at the end of the day, don't, as an electrician, just go willy-nilly adding and saying, yeah, I can put this here or there and something like that. And you're in somewhere where that if you're in a room, a vault, or pit, and it does not have drainage to prevent water accumulation, then, again, most of those places like that will have some type of drainage. Okay, so that drainage rule is new. Okay, now, receptacles. Here's what I just read. At least one GFCI protected 15 or 20 amp receptacle supplied from a general purpose branch circuit. Nothing special. Nothing special. Okay. It's just from a general purpose branch circuit. It's in there for servicing, those type of things. Okay. To discourage the use of extension cords and things like that. It says at least one has to be, and it shall be located within an equipment room. Not just outside the door. Okay, I had one guy ask me that. He says, "Hey, Paul, but if I've got that receptacle that's going to be required, it's within 6 feet and 20 feet for the pool, can that be the one?" I'm like, "Well, where is it?" Well, if it's inside the room, then it doesn't meet that requirement. Okay, if it's outside of the room, it doesn't meet this new requirement. You have to put one inside. Okay, so it pays to know the code. Obviously, adding a receptacle when you get rejected, and David comes and rejects you, then you could easily put one inside of the pool area. But again, it brings us up to this other thing. Does that receptacle, is a plastic receptacle okay in the pool area? Remember, it's a corrosive environment. Ooh, don't get me started. Okay, NEMA folks, be careful what you ask for. Okay, you're now, at that point, you're going to have all kinds of special equipment. And then, of course, the device manufacturers are frothing at the mouth because they're like, hell yeah, we now got a new EVSE receptacle. We need a new pool pump room receptacle. Yeah, it's going to have a special little teardrop, a little water drop on it. It said, I'm just saying, if it can happen, it can happen, folks. I'm a manufacturer, but again, I'm promising you, if they can do it, they'll do it. Okay. All right. So it goes on to say, oops, let's go back here. It goes on to say all other receptacles supplied by branch circuits rated 150 volts or less to ground within an equipment room, or any receptacle supplied by branch circuit rated 150 volts or less to ground in vaults or a pit, okay, shall be GFCI protected. So you still have to have at least that one in there. It's got to be GFCI protected. But by the way, you're being a very generous electrician and you want to put more than one in there, they all still have to be GFCI protected, right? Makes sense? Okay. And let's see, what does David point out here? David says that's the Florida Building Code is based on the ICC series 2026 Florida Building Code. Effective 12/31/26 will be based on the 2024 ICC. Oops. And that references the 2023 NEC. My understanding, that's my understanding from previous adoptions. Okay. All right. Well, hopefully y'all get all that act together in Florida and get up to date on everything. All right. For many years, there was, again, no requirement for provisions of receptacle in a pool equipment room. Lack of such really caused and created a hazard because, again, when you're working on equipment, things like that, extension cords and all that kind of stuff. So, and also chemicals on the floor, dragging extension cords around, all this other type of stuff. And a lot of times they'd be plugging into something that may not be GFCI, or they had a receptacle in there and there was no requirement for it to be GFCI protected. They put the receptacle in there. So again, now we have provisions. Don't have to worry about that. Okay. Let's see here. All right. Next, let's talk about something. This is in part 1, right? And this is the maintenance disconnect means. Okay. Very misconstrued when we have other disconnect requirements for certain things. And this is a maintenance disconnect requirement. Okay. So it says one or more means must be provided to simultaneously disconnect all ungrounded conductors, not one leg, all legs, everything, right? Okay. All ungrounded conductors of a circuit supplying a pool-associated equipment. The disconnecting means is required to be readily accessible. Okay, so obviously it has to be readily accessible for the equipment, from the equipment that it disconnects, within sight, and we know what within sight means, right? So readily accessible and in sight go hand in hand. If you go into your definitions, you'll see something called in sight, which we refer to inside of, means that readily accessible is one thing. You have to be able to get to it without climbing over, climbing under, moving up obstacles to get to it, right? On this maintenance disconnect. Next, within sight means that it has to be no more than 50 feet from the equipment that it supplies, and it has to be within visual sight, okay? Not around the corner. So if it's around the corner, it may be within 50 feet, but it is not within what? Within sight. Two elements that have to be met here. Within sight, okay? A defined term, by the way. And located at least 5 feet. So this maintenance disconnect has to be at least 5 feet or more horizontally from the inside wall of the pool, spa, or hot tub. That's why it's a maintenance disconnect, and that's why it's in part 1. It's very general. So it's not just for pools. It's not just for hot tubs and spas. Okay, it's very general. Okay, now it says pool lighting is not covered by 680.13. So pool lighting, we got our own rules for pool lighting, things like that. There's pool lighting switches for pool lighting. Its distance is very similar, and we'll cover that when we get there. For that type of thing in 680.22, and we'll look at things like 680.23. Right now, just maintenance disconnect. That's what it is. It's not the same as a pool light switch, even though that is a disconnect, form of a disconnect, not covered here. That's not part of 680.13, okay? All right, next, 680.14. We're talking about all those wiring methods that we talked about. First one right here. Wiring methods shall be suitable for corrosive environments, okay? All of those haters out there that do not like PVC jacketed MC. Again, I hate to be the bearer of the well, yeah, this one I like to be the bearer of this. Let's go look at 330. Now again, if you want to say, Paul told me I could do this, you need to check with your AHJ. They may have a rigid enforcement, pun intended. But what we look is right here. So use is not permitted. So use is permitted. So use is permitted says that MC cables shall be permitted as following. MC cable, metal clad, okay? Interlocked version, okay? But this applies to all MC, by the way. All right, so down here, it says in damp and wet locations. It was my proposal that got this damp added, by the way, because it never said that before, okay? So it is permitted in damp and wet locations where, read this, folks. This is where the code panel, this is where I had them go crazy on code panel 17 when they wanted to argue about it. It says right here, in damp or wet locations where a corrosive resistant jacket is provided over the metallic covering and any of the following conditions are met. Number one, the metallic covering is impervious to moisture. That would be like an MC, that would be like interlocked or a smooth type of MC, okay? It's impervious to moisture. It can't get through the metal. It's welded or it's a solid extrusion. Or a jacket resistant to moisture is provided under the metallic covering, all right? Well, we're not gonna do that because I'm putting it on the outside, right? I'm putting the corrosion resistant over the metallic covering, okay? So I'm not gonna do this one. These are too expensive. What about C? It says, the insulated conductors under the metallic covering are listed for use in a wet location. Did it pay to argue with me during the Code Panel 17 meetings and the hearings? Yeah, they ended up getting a lot of what they wanted, but it says right there, us as a manufacturer, we actually did a test. We actually took our MC cable with the PVC jacketed sheathing extruded on it, and we put it in a container of hydrochloric acid. Worst case scenario, not watered down, 100% hydrochloric acid. We put it in there, we sealed it, we put it out in the sun, and we left it for almost a year. It did not break down the PVC jacket. If I'm already allowed to use PVC material in those locations, right? As you see right here, it says right here, I'm able to use the wiring methods. It says rigid intermediate metal conduit, rigid polyvinyl chloride PVC, all that, okay? It even allows this, liquid tight flexible metal conduit. Guys, that's almost the same as MC. In fact, our PVC extrusion over the MC is probably more robust than liquid tight flexible metal conduit. Yet I had to argue with these folks about it. Again, this is what I deal with, guys. And even on code panels, it was like pulling teeth. Why? Because people have agendas. People have agendas sometimes on these panels. So again, we have to be careful with that, okay? I like to not think that way, but anyway, there you go, okay? All right. Oh, let's see here. So anyway, there you go. But again, you can't use aluminum conduit and aluminum tubing. That isn't permitted. There are manufacturers that make aluminum EMT, aluminum rigid and all that. That is not permitted, flat out, okay? Now notice this. It says, with all the changes that have taken place in 6.8.14 in the past two cycles, the following question is common. Can PVC covered jacketed type MC cable be used in or near a corrosive environment? Okay. Well, it says PVC jacketed type MC cable are listed and identified for use in a corrosive environment, such as those that fall under 310.10A11 and that meet the construction parameters expressed in 330.12.2 are permitted in a corrosive environment as covered in the installation requirements of 680.14. Recall that the term corrosive environment as defined in Article 100, PVC jacketed MC has been used in corrosive environments such as direct buried installations and exposed to cinder fills, chlorides, caustic alkalis, hydrochloric acids, and vapors in chlorine conditions for decades. It's been used all the time for pump motors, for pool applications, both residential and commercial. In fact, the use of type MC with PVC covering jacketed has proven track record in pool pump motor applications in 680.21a1. It's been like that for decades. By the way, I wrote this, if you want, for the publication. This was in our residential product that was produced. I helped write this because I did all the research on it, okay? Also, as you can see how anal I get into these things, I went into deep detail, right? And again, it also requires that it's important to note that nothing within UL 1659 standard, that's the MC cable standard, by the way, the construction standard for MC requires any special evaluation or marking to allow compliance with the intended use, okay? While there is language in 41.10 of UL 1659 that permits markings on the outer covering for the words suitable for use in swimming pool motor circuits, that is not mandatory. It is purely optional. Okay? So important for everybody to understand these types of things. And this is why I do what I do, because I cannot stand when somebody may make you do something that you're not required to do just because they don't understand. Okay? Trust me, PVC jacketed MC is going to be around as long, if not longer, than EMT thrown in the ground. And guess what? EMT is allowed if it has a protective coating that the manufacturers typically all put on it, a zinc coating. It's going to last as long, if not longer. Why? Because our MC, the armor has a zinc coating on it as well, or it's aluminum, and it also is protected by a thick PVC material, and it is rated for direct burial use. So again, at the end of the day, it's a very shallow argument by all of those that argue that PVC jacketed MC can't go in there. You can't rewrite 330. You can try, and they did try, by the way, but it is what it is, okay? Soapbox. All right, boy, I've gone 2 hours today. Wow. God, I thought I was going to do an hour. Whew. Okay, all right, so let's do this. That was everything we kind of went over, kind of a synopsis in part one and things like that, right? Okay, so here we're going to get into permanently installed pools, talking about part two. So that is where we're going to leave off, and we're going to talk about all the general requirements that we're talking about in dealing in part two. So all of that stuff that we just talked about just now was kind of a part one coverage. Tomorrow we will get into part two, and maybe obviously in part two we will get to equipotential bonding, so we'll move a little quicker. I again apologize for taking up all your time for that. So let's go real quick to some giveaways. We're going to do just a couple because again I've kept you too long, so we're just going to go to a couple. Hopefully you don't come here and join us just for that. I would think the prize is the fact of the education you get, but you know, I get it. It's always good to get some gibbies. So let's do this. Yeah, Poppy uses, so yeah, PVC makes life much easier, right? No longer have to worry about bonding issues when you got PVC. I'm just saying. You know, some people like the look of a rigid and intermediate, but Schedule 80, just as good, okay? So let's see, Marlon. There was a lot of extra tidbits in today's show. It wasn't just sticking to the material. I'm sure I'm going to get hate mail from somebody, right? I always do. That says, you're just too long-winded. And you know what? That's because they have no life of their own. They need to go, and you don't need to be watching me. Okay? All right. So you're in the drawing, Marlon, for the voltage drop card. Congratulations, you're in that drawing. Dude, I could say one word out my mouth and somebody would say something nasty on social media. I can guarantee you the people that are watching now, there is at least one hater just waiting. My point is, why are you here? I've just consumed 2 hours of your life you'll never get back. So if you're a hater, I just consumed 2 hours of your life. Who's winning now? Oh! All right. So Charlie. All right, Charlie, you're in the drawing for the North. Am I ever going to change that? You're in for the 12-month of Trade Hog drawing. I'm going to have to change my grammar on these things, fix my stuff. All right. No lunch for me today, but y'all got all the goodness. I think you already have that. Let's spin again for you. Santana. Yeah, you can't increase your odds by putting more #wins. You increase your odds by watching us on all of those channels. Like watch us over on the Tube, watch us over on YouTube, Facebook, then, okay? Christopher, I think you have won one of these before, and I think you said you don't want it. So I'm going to spin again for you again. My memory is not the greatest, but I'm going to spin again.
Woo, 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 woo. Big dog.
Okay, ultimate coin. You're in the drawing for the ultimate coin. Okay. All right. All right. Oh, you want it? You want the, would you, or what do you want? Let me know, Christopher. Do you want to get in the drawing for the coin, or do you want a wire waffle? These are a rare commodity now. I think they're sold out. Do you want your waffle? Okay. All right, you want the wire? Okay, no worries. Send me an email with your address on it, and we'll send you the wire waffle. All right, folks. I have kept y'all way too long today. I appreciate your patience. Sorry I took so long today. I appreciate all of you for sticking in with it. It's again, I am long-winded because I have so much that I want to share before my time is done, and so I will always be long-winded. I can't help it. That is just me, okay? It is just my nature. And some people like it and some don't. I get it. But it's just the way I am. So I appreciate all of you that hung in there with us. Those that dropped off, I get it. Life calls. I will catch you tomorrow where we will dig deeper into this topic and we will go into part 2. And that is the meat and potatoes. Because there's a whole lot of other definitions you folks should read about pools and spas and hot tubs. Don't get me wrong. There's a lot more to unravel in part 1 that you really need to take the time. That's your homework tonight. Go back and look at 680. Look at part 1. If you got any questions, bring them to tomorrow. I'll jump back and answer them if it pertains to part 1. To part 2, we're going to get into those things that you asked today because I knew we were going to talk about it in part 2. Equipotential bonding, the grid, how that applies to pools, whether they're in ground or above ground and all that kind of stuff. We're going to cover that tomorrow. That's a teaser. Make sure you come back. Till next time, folks, stay safe. God bless. And thanks for taking time to join me here on Coffee Hour. Peace.